on this computer. Okay, so today, first off, let me just check the dates I laid out for the assignments, because that should give me an idea as to when I want to run the next exam, which is not going to be next week, so don't panic yet. The next exam, let's see. I want it to be sometime after the index tree assignment is done. Okay. And then sometime probably before the Cheaters Hangman assignment is done. So most likely the 4th or the 11th, depending on how I feel for that, or how we feel for that. And I am currently erring on the 11th in terms of that being done. So we'll see. But I'll let you know, at least a week in advance before you have your next exam. So just keep that in mind with regards to that. Next, I wanted to make sure that I went through something to figure for anybody who's still struggling with the Sudoku puzzle. Or still trying to figure out one specific part of the Sudoku puzzle, which is the part that I actually find the most difficult. Which is the 3x3 square. So right, if you've got a Sudoku puzzle, right? The Sudoku puzzle itself is made up of, it looks like this big 3x3 grid with each, it's a 9x9 grid, but it looks like a 3x3 grid, and each of these squares have a 3x3 grid inside of it. And one of the rules is to check that box for any duplicates, right? So if I've got the numbers 1, 2, and 7, I can't have a duplicate 7 somewhere in this 3x3 box. Okay. So how in the world so let's go ahead and assume that this is our 3x3 grid, right? This is 3x3. It's part of a much bigger, it's part of a bigger Sudoku puzzle. Maybe it's at the top. I'm not sure where it is. It could be the middle square, right? Okay. And so the way we want to check basically to check for duplicates in a box is, given a square like this one over here, given this square over here, I want to figure out what so given like this is our row, so it is this row, and it is this column. I want to figure out what this space is. I want to figure out what the X is. Now, why is that? Because once I figure out what the corner of my space is, okay, once I figure out the row corner and the column corner, I can write a fairly straightforward for loop to take care of that, or straightforward nested for loop. For I equals 0, I is less than 3, I plus plus, and then for j equals 0, etc., right? So the 3x3, and then all you have to do is check with an if statement if board, or whatever you call it, board, row corner plus I call corner plus j, right? And so you just kind of iterate over this 3x3 by starting at the corner and just going through all possible combinations of plus 0, plus 1, or plus 2 on the rows and the columns, right? Notice that we have I here and j here, so those allow you to get through all possible combinations of that 3x3. Okay, it just matters. So for instance, if our corner is one of 3 values, okay? It's either going to be 0, 3, or 6, because if we've got the Sudoku puzzle, right, the top left corner is going to be the top left corner of the puzzle itself is 0. And then if you've got, and if you're move over to this box, say over here, this 3x3 box over here, the top of this 3x3 box, this would be 0, row 0, column 3. This would be row 0, column 6 over here, right? Makes sense. So those positions, you've only got 3 combinations for each of those. So the row and columns can respectively each only be 0, 3, or 6. So there's 2 ways to kind of go about to figure out what your to get what your column is, or what your corner is. Okay. The first is the I don't have time for this approach, which I've seen a number of students do. That's perfectly fine. It is basically, well, if there's only 3 possibilities for what my row corner can be, and only 3 possibilities for what my column corner can be, then that's just only 6 checks I have to make in total. So I can say, hey, if my row is between 0, 1, or 2, then my corner's 0. If my row is 3, 4, or 5, then my corner is 3. And if my row is 6, 7, or 8, then my row corner is 6. And so you just make that 3 checks for your row corner, make 3 checks for your column to figure out your column corner, which of those conditions is true, and then you've got your corner, and then you run that loop, and that's what you've got. The other approach to do that is to use math. Now there's 2 ways to use math. The first is you can use division, just straight up integer division and multiplication, which is the way I kind of figured out how to do it myself, which is simply put, we've got a 9x9 grid, and if you divide by 3, if you divide your 9x9 coordinate by 3, that gets you basically which of these big squares am I in? And then you can go from there to figuring out, and then it's just a simple arithmetic step to go from that to figuring out what your big corner is. Not going to fully reveal it. The other way is to use modular arithmetic, right? If I'm in square 5, then my corner is 3. If I'm in square 4, my corner is 3. If I'm in row 4, my row corner is 3. If I'm in row 5, my row corner is 3. If I'm in row 3, my row corner is 3. Right? So basically, we can do some modular arithmetic and some subtraction to figure out what our corner is there. So there's different ways to do it. If you cannot figure out that math and you just want to go for the I don't have time for this approach, I have other things to do with my life, then that's perfectly fine. And I'll be happy when you demo it. I'll be happy to show you how to solve that in detail. Again, with the and finally, the final statement I want to make is that when you're writing your solve method, right? When you're doing this, as I mentioned the first time when I displayed this puzzle, right? It should take in your, in-array board, or whatever you want to call it for your Sudoku board. And you should take in where you currently are, which takes one of 2 forms. It can be int row, int column. So your position gets split into 2 things, right? What row you're in and what column you're in. And the way you go through is you just simply increment your column or your row, most likely your column. Or your solve method looks like this. This is also kind of valid, and I've seen some students do this, which is int board. We take in board just like the other one. And here what we do is we take int position in. Okay. And then what we do for our first step there is we say basically int row is equal to position divided by 9, and int column is equal to position mod by 9. And that allows you to take that single variable and split it into 2 variables if you want to do it that way instead. Right? because dividing by 9, it says, okay, because first position would be the 0, 0 corner, then 0, 1, then 0, 2, then 0, 3. So dividing by 9 would basically say, okay, we're in row 0. Then when you've gone to the second row, that'd be at least 9. So dividing by that 9 would give you 1. Whereas column, by doing the modulo, that giving you the column, that lets you know which column you're in. Because that would give you the remainder, what's left over from your position. So, and then, but regardless, if you do this or this, once you've got your own column, the rest of the puzzle pretty much follows identically, which is you check to make sure that you're in the appropriate, that you're not out of bounds or anything like that. All right, any other questions about this before I go around and help people? I will say about that the index tree problem is one I always say I'm going to replace with a more difficult one, and then I don't because I find the semester's already being difficult enough for the students. But that one, I find interesting because even though it's a bit more, it's not as difficult as a problem, it does have that whole mental hurdle that, oh, I've got a data structure made of nodes, but each of the nodes also has a data structure in it, which is a list. You know, the idea here is that a node can hold whatever we want it to. We can have a node hold basically a collection as its single item. And the collection can then hold multiple items. Or it can have, in preparation for us learning about maps, keys, and values. All right, the last thing I want to mention before I go around and before I forget about it is, of course, I mentioned this in class, but it may not have been fully communicated with everybody. We do write for the ChatGPT questions. Please feel free to make corrections to those, and I'll be happy to give you back the difference on points. Feel free to collaborate with others on that. And the phrasing that I want to use, it's not a good or bad question. It's a valid versus invalid question. Does the question make valid sense versus does it not make a valid sense? And that can be, get to that to me when you can. I would prefer sooner rather than later. But again, just get that to me when you can. I understand that things have been insane since COVID, and time has been nonlinear and hard to measure. So I totally understand if things are still that way. All right, so I'm gonna stop recording now, and I'll go around and help you.